All right, so in this video, we're going to go over some of the questions from this Jeopardy review. Remember, not all of them, but I'm going to go over a decent amount on these. So the ones circled are the ones that we will be going over. If you need to go over any of the other questions, and use what we did in the questions here, because this kind of covers all the different types. It covers solving and or compound inequalities. It covers going over special cases. It covers going over just all the different types. So although I'm not going over all of them, you can use this to help you with the other questions. And if you need any other help, you can always feel free to reach out through email. All right, so for the first question, we're doing solve and graph, and we're given this compound inequality. So we have 4x is less than 8, and x over 3 is less than or equal to -2. So you'll be asked to both solve and graph for all these types of questions. So when we have these compound inequalities, we need to identify what type it is. And they tell us it's AND on here. So we know it's an AND statement. So we're going to solve both of these inequalities separately. So we have x is less than 2, and I'm going to change this color. I'll do it in blue. This one will multiply each side by 3 to isolate that variable x. And x is less than or equal to -6. All right, so now once we get these answers, then we are going to have to graph them. And on your test, you'll be given just a blank number line. So you'll have to go ahead and create the number line for this. They're kind of far apart, and they're both even. So I'm just going to go ahead and count by -2. So I'll do -8, -6, -4, -2, 0, 2, and 4. All right, and then we're going to plot each graph. So x is less than 2. So since it's just less than, it'll be open circle at 2. And then it's going to the left for it's less than 2. I know I'm going to go through these kind of quickly, but this is a review at this point. And if you need help with actually identifying how to graph, then please make sure you're reaching out. Here, it's going to be a closed circle at -6, and it's going to be going less than, so it's also going to the left. So remember, when we're solving, we're looking for an end statement. We're looking to see where do they overlap. So the part where they overlap is here. So that means that this blue graph will cover all of our answers. So our final answer I'm going to do here in red is this here, all right? The green and the blue grasses help us to generate what our final answer is, and you don't actually have to graph both of those on your test if you can look at this and identify what your final answer is, but it can help us because we know that we're looking for them to overlap. So our final answer is the red graph here, and then we will write it final as x is less than or equal to -6. That will be the final way that you write your inequality as well, because even though this is an end statement, since this is our final answer, it includes all of these x is less than 2, so we only need to write this one inequality. All right, now our next problem that we have is -2r is greater than or equal to -10, or 4 plus r is greater than or equal to 1. Anytime it's an or statement, we will have to give you the word or. So if you don't see an and or an or word written, then it means it's an and statement, because we can write the and compound inequalities in a couple different ways. One way with the word and, like we did on that last question, or one way without it. All right, but anytime that we want it to be or, you will definitely get that word. So if you don't see the word or, you know it's and. So I'm going to solve both of these individually. So I divide each side by -2. When I divide by -2, I got to remember to flip my inequality. So now r is less than or equal to 5. Or this one, I just need to subtract to 4 because it's a +4. Or r is greater than or equal to -3. So once again, we're just going to plot these. These are a little bit far spaced out, and they're both odd, but I can go ahead and count my number lines by -5, -3, -1, 1, 3, 5, and 7. I don't need to have 0 plotted on my number line, so I can just go ahead, since they're both odd, I can just count by 2s, starting with an odd number. All right, now here, r is less than or equal to 5, so there's my green graph. Our blue graph, r is greater than or equal to -3, closed circle going in the other direction. Now remember, it is an or statement. So when it's or, and there's an overlap like that, especially going in both directions, we know, okay, there's something special about this problem. And since it just has to satisfy one or the other, doesn't need to satisfy both at the same time, every single number here is covered. So this is infinitely many solutions, or you can go ahead and say all real numbers, or you could give me the symbol for a real number system, and I'll accept that as well. All right, so any of those would be acceptable as an answer. All right, so now we're moving on to the absolute value inequalities. You're going to see The only difference between what we were just doing with compound inequalities and absolute value is the compound inequalities, we flat out give you all the questions. There's nothing you need to think about until you start solving and get to your solution. However, for absolute value, you will create your compound inequalities. So you are doing, from here, you're going to generate the two inequalities on your own, but they're almost identical except for you are creating instead of just given the compound inequalities. So remember, our first step for absolute value is we want to isolate it, meaning there's nothing being multiplied, added, or subtracted, or divided to our absolute value. It's not everything, nothing's being done to it, so it is isolated. Once you then isolate, you want to figure out what type of compound inequality this is. And remember, less than is going to be an and compound inequality. And then once you do that, you're going to generate two separate inequalities. Your first one, you just get rid of your absolute value sign. So x plus 5 is less than 9. You write it exactly like it is. Your second one, you write exactly what was inside your absolute value again, but now we're flipping our inequality and making it negative, right? And then we know that this is an and statement. And once we set this up, now it's exactly what we were just doing. So we're just going to solve these individually. So we subtract 5 from both sides. So x is less than 4. And then I'm going to go ahead and solve this one where I'm going to subtract 5. So x is greater than negative 14. All right. Once we solve them, we're now going to go ahead and graph. All right. These are pretty spaced out. I am going to just count by 2s again. So I'm just going to pause the video and write this. All right. So this number line ended up having a lot of numbers on it. We can count in different ways. We could have counted in 4s and then approximate one of them in half. You could have made this a little bit easier for yourself. But this is the way I decided to do it. So x is less than 4 is an open circle at 4 going to the left. X is greater than negative 14, so it's going to be an open circle going to the right. And remember, when it's an and statement, we're looking to see where they overlap. So they overlap here. So our final answer will be an open circle of both negative 14 and 4, and then a line connecting those two. All right, so writing it out, this would be our written out answer, and then our graphed answer would be the red graph. All right, so remember, some of these problems with absolute value may look really difficult, but they're actually the easiest problems that we will have. So once we isolate that absolute value, then we can start, before we start doing anything, we should look at this problem and say, okay, what is happening here? And I know every single time that I solve or plug in a value for x, no matter what I plug in, from negative 1 million to positive 1 million, after I take the absolute value, I'm going to get a positive answer. So this is saying that after we take the absolute value, that this positive answer is going to be less than or equal to negative 22. Well, is it possible for a positive number to ever be less than the negative? No. So this answer is actually no solution. And you didn't actually need to do any work for it if you were just able to identify and interpret what's happening. That this absolute value will give us a positive number every single time after we plug in. No matter what it is, from negative to positive number, after we take the absolute value, it becomes positive. And a positive number can never be less than a negative. So therefore, it is no solution. All right, so when we go to answer this question, the first thing we have to do is isolate the absolute value. So we can't do the positive or negative and flipping our inequality first, because if we were to make this, so if we were to subtract 8, all right, and then I get, actually, let me write this, the absolute value of 4v minus 7 is greater than or equal to 9. All right, that's what we should do first. If you were to try and make this negative 17 to begin with before you isolate, when you subtract, you're getting a different answer. You're getting negative 25, which is not the same as 9. So because it's going to be different if we try to make this positive and negative too early, it's not going to give us the same answer, because now we're setting the absolute value equal to two different things. So you must isolate first before you figure out what our two absolute values are. Then once we isolate, then we look and say, okay, what type of statement is this? It's greater than, greater. So it's going to be an or statement. So this is going to generate two separate inequalities. 4v minus 7 is greater than or equal to 9. Or, and this is where we then make it negative. 4v minus 7 is less than or equal to negative 9. So we can't flip it and make it negative until we isolate. All right, then we'll go ahead and solve. So we'll solve them each individually. So I'm going to add 7. So 4v is greater than or equal to 16. Divide by 4. V is then greater than or equal to 4. Or add 7. 4v is less than or equal to negative 2. Divide by 4. V is then less than or equal to negative 1/2, which is just reducing that negative 2 over 4. All right, now I'm going to go ahead and graph these. So I see I have a half. So I'm just going to go ahead and I'll approximate that. So I'll have -2, -1, 0, 1, 2, 3, 4, 5. Now I'm just going to go ahead and plot these graphs. So it's greater than or equal to 4, so colored in circle going to the right. Less than or equal to -1/2, which is then approximately in between -0 and -1. That's going to the left. Or statements, we don't have to worry about them overlapping. If they do, that tells me it's a special case. So this is our final answer, and that is it for this question. All right, so now this is the last question we're going to go through, and it's just graphing an inequality. It's all the same steps for all of them, which is why I'm only going through one. But we need to graph this. And when we graph it as if y is equal to -7x plus 3, because we're graphing our boundary line first. All right, so we're graphing it like it is in the equation. So if leaving it as an inequality confuses you while you're making your line, change it to an equation, graph that equation, and then think about it as an inequality. But the first thing we need to do is we need to graph our y-intercept, which is our b. And our b is our constant. It's being added or subtracted, so it's 3 in this case. And that generates an order pair of 0, 3. So I can plot that here. Right, then the next thing that we need is we need to find our slope. And our slope is our coefficient of our variable. So it's what's being multiplied to our variable. In this case, it's -7. Now remember, we think about this as change in y over change in x. So we will write this as a fraction of -7 over 1 because every whole number can be written over 1. And this is telling me how I'm moving to generate my next point. So my change in y is a -7. So I'm moving down 7. 1, 2, 3, 4, 5, 6, 7. And my change in x is a +1, which goes in the right direction. So I'm moving to the right, 1, and there's my point. Right? Then we're going to draw our line. You will use a straight edge. It's hard for me to use a straight edge while using this tablet, so I'm just going to be drawing it, so it's not going to be perfect. But you'll use a straight edge on your test. And then we're just drawing a line connecting those 2 points. When we draw the line, we need to figure out, is it solid or dotted? And since it's equal to, it is a solid line. If it's just less than or greater than, then it is a dotted line. But this is what our graph will look like. Right? And then after we graph it, we then need to figure out which region are we shading, this region here or this region here. And the way we do that is we pick a point that does not fall on the line. So 0, 0 does not fall on this line. If I were to graph this with a straight edge, you would see clearly it does not. So that's the one I'm going to pick. If you think maybe it's too close to call, we can then pick -1, 0, and that's the one we'll do now then. So we'll test the point -1, 0. Plug it back into your original inequality. Is 0 less than or equal to -7 times -1 plus 3? Well, is 0 less than or equal to 7 plus 3? Is 0 less than or equal to 10? Yes, it is. So that means that all the points, since this point worked, that means all the points in this region will also work. So we will shade this region below it, and that will be our final answer. All right, that is it for this video. If you have any other questions or need any other help, please just let me know.